Well, this is the second video on section 2.4, going over rational inequalities. And so I'm just going to go over these last four even numbered problems on page 107 as examples. So let's see, let's start with problem 10. We've got x squared plus 4x plus 3 on top, and 2x plus 1 on the bottom, and we want to know where that's going to be less than 0. So I think I'll identify the roots and asymptotes first, and then we'll look at the graph and match up what we calculate with what we see on the graph. So the roots, of course, come from where the numerator is 0, x squared plus 4x plus 3 equals 0, and the asymptotes 2x plus 1 equals 0. This one's easy. 2x is negative 1, x is negative 1/2. So we should see an asymptote where x is negative 1/2. This one, the x squared plus 4x plus 3, is actually factorable, but you can run it through the quadratic formula as well. And we should get answers of negative 1 and negative 3. So that's what we should look for on the graph. That's going to direct our attention to those places. So let's get the graph going on the graphing calculator, and then I'll sketch it on the board and show you what it looks like on the calculator as well. Let's see, so x squared plus 4x plus 3, and then 2x plus 1 on the bottom. So we've got the asymptote at negative 1/2, and then we've got those two roots at negative 1 and negative 3, and there's the asymptote at negative 1/2, and then we've got this graph coming down and doing something like that. Let's see. Let's get the focus here. So there's what it looks like on the graph. And again, if we go into the table, because those two roots are whole numbers, so you can see when x is negative 3, y is 0. When x is negative 1, y is 0. And we don't see the asymptote on there. We don't see that error message on this one because the asymptote is not a whole number, so it doesn't show up in the table. Okay. So that's it for the critical values, and now we want to answer the question, where is y less than 0? So you've got this region in here where y is less than 0, and then that region out there as well. So this one, we would say x is less than negative 1/2, but greater than negative 1, or x less than negative 3. All right, let's see here. Okay, let's look at problem 12. So that one, we've got x cubed plus 2 on the top. And then x squared minus 2 on the bottom. And we want to know where is that going to be greater than 0. So for the roots, we'll get x cubed plus 2 equal to 0. And for the asymptotes, x squared minus 2 equal to 0. So this one, this is a quadratic. We talked about this in part 1. You can solve this on the quadratic formula with a equal to 1, b equal to 0, c equal to negative 2. I also talked about how you can solve this just by moving the 2 to the other side, square rooting both sides, but you have to be careful because you want both positive square root 2 and negative square root 2. If you run this through the quadratic, you'll get both of those answers. The roots Here you can cube root negative 2, right? If you move this to the other side, x cubed is negative 2. And I'll go ahead and cube root that. Let's see here. Cube root negative 2, negative 1.260. And that comes from cube rooting both sides of the equation. And of course, because it's a cube root, we don't have to worry about plus and minus like we did over here. Okay, this we could have gotten off the graph, and I'll show you that in a minute once I get the graph sketched here. Let's see, so the numerator x cubed plus 2 on top, x squared minus 2 on the bottom. And let's see what we get. So we've got these two asymptotes at plus and minus square root of 2, 1.414, and negative 1.414. And again, the calculator won't go in and find these for you. The asymptotes you have to solve by solving this equation. Sometimes if they're on whole numbers, you can see them in the table, but that won't always be true. The roots you can get off the graph. Let's see, let me finish the sketch here. Kind of does something like this. And then this one comes down and does that. And then that third piece is over here like that. And let's see, so this root right here, of course, this is negative 1.260. Now, I've talked a little bit about the difference between these yellow calculators and the older models that have the black plastic casing. On those older models, the graphics are not quite as sophisticated, and so when you get these situations where the root and the asymptote are right next to each other, it can be kind of hard to see, and it's really helpful for you to zoom in on that to get a better picture of what's going on with the graph. So let's see here. Let me show you what the graph looks like on the calculator. So there's the calculator. And there's what, let's see, let's try that again. Getting some reflection from the lights here. Oh, the calculator, there we go. All right, so there it is. And again, if we want to go in and find that root on the calculator, right, you can do second trace, choice number 2, and then you've got to back up to set a left bound. There's a left bound. And then arrow past it, there's a right bound. And there's the calculator giving us that same information that we saw for negative 1.2599, which I rounded off to negative 1.260. Okay, so we've got all our critical values identified. So now we're ready to answer the question, where is y positive? So that's going to be this region out here. And it looks like this little tiny region in between those 2 points right there. So that's x less than negative 1.260, but greater than negative 1.414, or x greater than positive 1.414. So that's it for number 12. Let's see, let's keep moving here. Number 14. Let's see. So there we've got 2x minus x squared on top and x squared minus 4x plus 6 on the bottom. And we want to know where is that going to be less than 0. Okay, so the roots are what make the numerator be 0, and the asymptotes make the denominator 0. So let's do the asymptotes first here. For one thing, we usually can't get these off the calculator from the graph. We have to solve this. So let's see. A is 1, B is negative 4, C is 6. And what we get from this one is complex valued answers, which means that we shouldn't see any asymptotes on our graph. Okay, when I make that graph, we're not going to see any asymptotes because these x values are complex. Over here, you can run this through the quadratic if you want. A is -1, B is 2, C is 0. So you can do it that way. This is pretty easy to solve by factoring as well. Factor out that x, and we should see roots at 0 and 2. All right, well, let's look at the graph and see what it shows us. Let's see, 2x minus x squared on top, and then x squared minus 4x plus 6 on the bottom. And what do we get here? Okay, so this thing comes along like this. There's our two roots, and we don't see any asymptotes. Here's what it looks like on the calculator. Okay. So this one ends up being pretty straightforward once you recognize that it's not going to have any asymptotes. So we've just got these critical values at 0 and 2, and so y is going to be less than 0 out there and out here. So that's x greater than 2 or x less than 0, and that's it for number 14. Okay, let's see, one more here. Problem 16. Got x minus 5 on top, and then 3x squared minus 2x minus 3 on the bottom. And we want to know where is this going to be greater than 0. So our roots are going to be what make the numerator be 0, and that's just going to be positive 5. And then the asymptotes are going to be where the denominator is 0. And so I'll run this through the quadratic here. What do we get? 3, -2, -3. And so we should see asymptotes at 1.387 and then -0.721. Okay. Oh, now we need to graph this. So, x minus 5. There we go. And then 3x squared minus 2x minus 3. Oops. Okay. That should do it. Right, so we've got an asymptote at 1.387 and -0.721, and then we've got this middle piece looking like this, and then let's see, this one is coming up and going like that, and it's kind of hard to see. It kind of runs right along the x-axis there. So I was kind of wondering, oh, is maybe there a root in here somewhere? No, there isn't. We found all the roots. The only root is over at positive 5. And so over here, as this thing comes up like that, it's really hard to see on the graph. But because we solved for what makes the numerator be 0, we know that there's a root at positive 5. And I'll show you, you can also look in the table and see that when x is 5, y is 0. And let's see, let's put these values in, 1.387, and this one, -0.721. Okay, so let me show you what it looks like on the graph. So there's the graph right there, and this is what I was saying about like this section over here versus this section over here. They look the same, and it's kind of hard to tell whether or not there are any roots in there. That's why we want to solve algebraically so that we can see exactly where those are. And there it is. You can see where x is 5 right up here, where x is 5, y is 0. Okay, so that's one way to confirm that we've got that root there. Whereas we don't have any roots over here. This thing is always going to stay just below the x-axis. And that's something else that you can see in the table. Here, actually, while I've still got it up, we'll take a look at that. And you can see for these negative x values at the top here, you can see those y values are all negative. And if you start scrolling up, you can see they just stay negative. Okay. So now we're ready to answer the question, where is y greater than 0? Well, that's going to be in between these two asymptotes, and then this region out here where x is greater than 5. So we'll say x greater than 5, or x less than 1.387, but greater than negative 0.721. And that's it for section 2.4. Okay, so we split this up in 2 pieces. You'll have 2 quizzes on this section, and then we'll keep making our way through chapter 2. If you have any questions about this, please let me know. Thanks a lot.